Good morning, everyone. I am Elenita Capsa. The topic that was assigned to me is about unified modeling language. The presentation outline that I'm going to discuss to you is what is modeling, what is UML, understanding the basic of UML, two main categories of UML diagram. So we have two types of category. We have structural diagram, behavioral diagram, and then the UML online tools that we can use. We start on the modeling. So when we say model, these are the abstraction that portray the essential of a complex of a problem or structure by filtering out non-essential details. Describing a system at a high level of abstraction, a model of a system used for requirement and specification. It also helps us to organize, visualize, and understand and create complex things. So, do we really need this kind of model in terms of developing a software system? What is modeling? Visual modeling. So when we say visual modeling, it is the way of thinking about the problem using models organized around a real world ideas. So it's basically models are useful for understanding problems on how can we communicate our system to different types of entities in our software development, and what will be our modeling enterprises. And this will be also a format on how to prepare documentation about designing programs and databases. This is an object-oriented modeling, the evolution of object-oriented development methods. So way back in 70s and 80s, we have structured programming design and analysis. And when the time comes that it is 80s and 90s, the object-oriented programming design and analysis was born. UML, it stands for Unified Modeling Language. It is an industry standard graphical language for specifying, visualizing, constructing, and documenting artifacts of an object-oriented system under development. So basically, UML mostly is a graphical notation to express the object-oriented analysis and design for a software project. So for me, UML is like a blueprint in creating a software program and in designing a software program. This will be one of the guide that will help in developing a certain program that is being put up. And also, it also simplifies the complex process of software design. UML also combines several visual specification of techniques such as class diagram and sequence diagram. If we are talking on the object-oriented principle and concepts, we are already taking into consideration its encapsulation, abstraction, classes, and objects. So why UML for modeling? Why do we need UML for modeling? As we said, it is a graphical notation to communicate more clearly that natural language and code is too detailed, while natural language is imprecise. It also helps us to see the overview of the system. That is why it's like in building a house, we already have a blueprint of how the house will be built. In animation, it's also a script. What will be the flow of the movie? So in system development, it will also help us to view what will be the flow of the program or the program that we are designing. UML is not really dependent on any language or technology. It's always UML never depends on what type of programming language we are going to use, and it moves from fragmentation to standardization. UML diagram. If we mean for functionality, we can use the case diagram. If we mean for decomposition, we can also use class diagram, package diagram, deployment diagram in terms of architecture. If we are considering its behavior, we can use the state diagram or activity diagram. If we mean for communication purpose, we can use the sequence diagram, collaboration diagram. There are two main categories of UML diagram. So we have the structure diagram and behavioral diagram. On my topic, I'll just discuss one structure diagram, which is class diagram, and then most of the diagram that I'll be discussing will cover the behavioral diagram. So these are the UML diagram types or categories. We have the structural diagram and behavioral diagram. So under the structural diagram, we have the composite structure diagram, deployment diagram, package diagram, profile diagram, class diagram, object diagram, and component diagram. Under behavioral, um, we have state machine diagram, we have communication diagram, use case diagram, activity diagram, sequence, timing, and interaction overview diagram. So let's start with use case diagram. So here in our image, the moment that we are explaining on how a system program, we are trying to explain to our client, it's really quite confusing on how can we let our client understand the flow of a certain application. So the suggestion for this is we can use the use case diagram. So use case and use case diagram are used in requirement specification phase. Use case document the behavior of the system from the user point of view. So by user, we mean anything external to the system. So it can be another software system interacting with software system being specified. So in use case diagram, we can use the following entity. So we have the system, serve as the rectangular, it's like a door, and then we have the actors, the stick man, and then we can use the oval as cases, and then the double arrowed line is in relationship. So actors in use case. So actor is a role played by an outside entity that interacts directly with the system. So an actor can be a human or machine or a program. So actors are shown as stick figure in use case diagram. So we have an example here. A stickman can be considered a customers. It will vary on the different system that we are developing. If we are developing enrollment system, our actors will be student, and then the other secondary actor will be the registrar. If we mean for invoicing system, we can consider it as client, um, and so on. So use case describe the possible sequences of interaction among the system and one or more actors in response to some initial stimulus by one of the actors. So each way of using the system is called a use case. So a use case is not a single scenario but rather a description of a set of potential scenarios. So for example, installing a database. So installing a database, we can add a new user to the database. So individual use case are shown as name ovals in use case. So installing a database is one of the case that we can do. So later on in our discussion, we will be encountering different type of cases. Also, a use case involves a sequence of interaction between initiator and the system. It's possibly involving other actors. So in a use case, the system is considered as black box. We are only interested in externally visible behavior. Description of use case should include events exchanged between objects and operation performed by the system that are visible to the actors. So in case of a bank, for example, performing a transaction of the counter. So sub-cases should include, say, making deposit, making withdrawals, etc. So together with exceptions such as overdrawn or account close. So apply loan can also use as a separate case since it is likely to involve very different interaction. Here in our slide is combining of use cases. We can consider this as an extension or extend use case. So a use case extends is another use case when it embeds new behavior into a complete base case. Say for example, check baggage extends the base case check in for flight. So you do not have to check baggage to check in for the flight, or it's vice versa. We have to check in for flight, which is the base case, to check the baggage. So the difference between extends and uses: in the extends, the extended use case is a valid use by the case itself. In the use case, the use case which is using the other use case is not complete without it. So combining the use case, a use case uses another use case when it embeds a subsequence as a necessary part of a larger case. So uses relationship permits the same behavior to be embedded in many otherwise unrelated use case. Say for example, check in for flight use case uses assigned seat use case. So these are different cases, but the check-in flight use case can use assigned seat use case because they are interrelated cases. So in some of the reference, this relationship is called includes instead of uses. So here is the sample of a use case diagram combining use cases. So check-in for flight uses assigned seat. Upgrade seat can extend in check-in flight. Check-in baggage extends check-in flight. Actors here will be flight attendant and then customer. So defining use case. Specify some specific scenario for each use case. Plug in parameters if necessary. So it also determines the interaction sequences, identify the event that initiate the use case. Thus determine there are preconditions that must be true before the use case can begin to determine the conclusion. So identify the boundary of the application. The use case also identify the object outside the boundary that interact with the system. It's also classify the objects by the roles they play. Each role defines an actor, so each fundamentally different way an actor uses in the system in a use case. So here is an example of how to document use cases. So use case, for example, is place order. So who are the actors here? We have the customer. So the precondition here is a valid user has logged into the system. So what are the flow of events? The use case begins when the customer selects the place order. The customer enters his or her name and addresses. So if the customer enters only one zip code, the system should supply the city and state. So the customer enters the product codes for product to be ordered. So for each product code it's entered, the system supplies a product description and price. B, the system adds the price of the item to the total and then end loop. The customer enters the credit card payment information and then the customer selects submit. So the system verifies the information exception. So save the order as pending and forwards the payment information to the accounting system. So when payment is confirmed, the exception payment not confirmed. So the order is marked confirmed. An order ID is returned to the customer and the use case terminates. So there is an exception. So payment not confirmed, the system will prompt the customer to correct the payment. um, the post condition here, if the order was not cancelled, it is saved in the system and marked confirmed. So another document case that we can see here on our slide is the flow of event. So the use case begins when the customer select place order. So this is the basic path. This is under the basic path. The customers will enter his or her name address. While the customer enter the product code, the system will respond. The system will supply a product description and price. The system will add the price of the item to the total and then end loop. So there are alternative and so on. There are alternative paths. So if in time before selecting submit, the customer can select cancel, the order is not saved, and then the use case ends. So in steps number 6, If any information is incorrect, the system will prompt the customer to correct the information. Okay, so in step 7, if the payment is not confirmed, the system prompts the customer to correct the payment information or cancel. If the customer chooses to correct information, go back to step 4 in the basic path. If the customer chooses to cancel, the use case ends. So here is a sample of an online resource HR system. So we on the actors here we have actor 1, 2, 3, 4, 5. So we have an actor 1, which is the employee. The current month is October and read only access. And then on the right part are the secondary actor, which is the manager, the healthcare plan system. This is the insurance plan system. This is the employee account database. So the employee can locate the employee and then it will link to the employee account database. The employee can also update employee profile and they will act by the manager. The employee can also update benefits and it will link on a health care plan system. The employee can access travel system and then the manager will be called on this action. And then the employee can access pay records. The employee account database will interact on the employee. So as you can see, in cases, it doesn't mean that it's only the actor, but it means that we can also consider actors such as the system and then the database. The online HR system, here is the documentation code for that. So the use case is update benefits. So who are the actors? We have the employee account database, healthcare plan system, insurance plan system. What is the precondition? So employee has to log onto the system and select update benefits. So that will be the option. So what are the flow of events? The system retrieves the employee account from employee account database and then the system asks employee to select medical plan type, uses update medical plan. And then the system will ask the employee to select the dental plan type, it uses the update dental plan. So what are the alternative paths for this? So if the health plan is not available in the employee area, the employee is informed and asked to select another plan. So here is an example of an online HR system in a combined cases. So employee, update benefit extension. This is the extension point name and then extension location is after the required enrollment. So on the top, we have different 3 cases that uses the update benefits extension points, update medical plan, then update dental, update insurance plan. At the bottom, we have the different cases we'll use as an extends. So select reimbursement healthcare and then select stock purchase. So there is an example of a use case diagram in an online shopping system. Remember that in all diagram that I'll be presenting to you, we will be passing through an online shopping system in a different diagram. So we have the customer. This is the online shopping system, and then other actors will be the service authentication, the identity provider, the credit payment service, and then the PayPal. So we have 4 cases in our online shopping system. We have the login, we have the complete view items, we have make purchases, and then complete check out. Next diagram that we'll be discussing is the class diagram under the structured format. So UML class diagram describes the type of object in the system. It is a static relationship among them. There are 2 principal kinds of static relationship. It's association between classes and a subtype relationship between classes. And then we have the class descriptions show as attributes and operation. So class diagram can show constraints on association. In classes, it is represented as a 3-part box. We have the class name, we have the attributes, and operation. So here is an example of a classes. So here in our diagram, The class name is the customer, the attributes is the name and address, and then the operation is plus credit string. So the operation syntax, we have the visibility name under the parameter list, and then we have the return type expression property string. Attribute syntax with the visibility name type is equivalent to default value. So we can also consider in this if we are making an enrollment system, the class name can be considered as student, and then the attributes can be also name and address or name or courses, and then operation is say plus courses and etc. So here's an example of a class diagram. Remember again that I'll be showing to you different diagram, but the system that we will be talking is online shopping system. Here's an example of a class diagram in an online shopping system. Under the parents class, we have this the entity. The class name is the user. So under the user, we have the attributes such as the user ID, string, password, login status, login details. So if we mean for a string, it's basically a text. Okay, and then we have the operation login verification and then login credential. This is the parents class, the user. Under this is the child class, which is the customer. So under the customer, we have the name string, address string, and then the shipping info is a string, and then payment details is a string. So what are the operations that we can do here? We can register, we can log in, we can update details. And then we have the other side, under the parents class user, we have the child class, which is the administrator. So we have the admin name, the string, its email, and then the string. What are its operation? We can update and then we can log in. Under the child case, we have the different class, which is shopping cart and then order. And then um, we have um, we have attributes that is composed of cart ID, product ID, and then quantity. What are its operation? We can add to cart, we can update, we can deliver, and then the payment. Under the child class also is the order. So we have here class name order, and then we have the attributes or the ID, customer ID, and then its operation, which is add order. And then under add order, we have the shipping info and order details class. So under the shipping info, we have the shipping ID, we have the shipping cost, we have the type, region, and then its operation is update shipment. And then the order details, we have the order ID, it's integer, it means number, and then we have the cost, it's also integer, quantity, it's also integer, and then the shipping ID, the string. And then what is operation is the payment details. Okay, association in class. So we have here a diagram on how to associate the classes. So here in our example, we have the class name order, and then its attributes is a date received and prepaid number is equivalent to string, and then its operation is money dispatch, and then its associated class is its role name is order product. So we have quantity, the price, and then it's satisfied. As association, multiplicity, one or more. So in association, there is a role. So a role can explicitly name with label. Role syntax is visibility name. Double colon type is equal to the default value. So roles have multiplicity showing how many objects participate in the relationship. So association can have multiplicities, a fixed value such as 1 to 3, or many denoted unlimited number, a range from 0 to or 3, or a set value of 2, 4, so generalization in class, it means sharing mechanism based on a hierarchical relationship between classes. So an arrow up indicates generalization. Under the customer class, we have the corporate customer and then the personal customer. How about the constraints in class? So it represents the further restriction on association or classes. So here in our example on object constraint language, it is a formal language for specifying constraint. So in our example, we have order class and then the customer. So here, our constraint for this diagram is if order.customer.credit rating is poor, then order is prepaid must be true. So that is the constraint under this class example. So we have another example of a class diagram that we can see the constraint, generalization, and its personal mm, indicates the credit rating on below is always set to poor for personal customer. So constraint order class, if order customer credit rating is poor, then the order is prepaid must be true. And then definitely indicate the anything that arrowed above that covers the customer information indicates the generalization itself. Okay, aggregation and composition. In aggregation is a part relationship. When we say aggregation is only a part of a relationship, but when we say composition, it is a part of a relationship, but part and whole live and die together. So say for here for an example, the billing under the order, the billing information should be always or it's a standard basically. Qualified association. So here in our example, the association can keep by the value of the qualifier. So in our example diagram, we have the order class and then the product order class. So its qualifier definitely is a product. So association in classes. It also adds attributes and operation to an association. So allows exactly one instance of the association class between any two subjects. So in our example diagram, we have the company, which is the employer, and then the person, which is the employee. So any associated class here is the job, the description, the date hired, and salary. So next topic is the sequence diagram. So sequence diagram can be used in conjunction with use cases at the requirement phase or at the design phase. They can be shown to show the system behavior that correspond to use case. So sequence diagrams can be used to generate test cases for the software product. And sequence diagram are similar to MSC's message sequence chart, which are part of the STL and have formal semantic. Component of a sequence diagram. So we have the object, an instance of a class shown as a box at the top of the vertical dash line. So this will be the format of our sequence diagram. And then we have the lifeline. So it's a dash line represent time flow. So instance name can be omitted. It means anonymous instance. So we have the components of a sequence diagram. We have the messages and then the special messages. Messages is the communication between objects. Say for example, in here in our example diagram on the right, we have the product order and then its messages will check the stock items. Okay, and then we have needs to reorder, another arrow back to the stock item. And then we have the special messages, which is a self-delegation. It shows returns only if adds to the clarity if it's will be creating or destroy. So components of sequence diagram. There are two kinds of control information. We have the message condition and we have the iteration marker. We have the following sequence. We have the order, product order, and then stock item. The message is the order will prepare, the product order, and then iteration marker. Message condition, if the checking will be if it's true, then we proceed on the stock item. Well, if it's well, possibly on the other side it's negative or not true, well then it's removed. So a sequence diagram shows a particular sequence of message exchanged between number of objects. Sequence diagram are also behavior by showing the ordering of message exchange. So a sequence diagram shows one particular communication sequence in the run of the system. It is not characterizing all possible run. So here is an example of a sequence diagram. So order entry will prepare the order and then it will go to the product order, it will prepare, and it will check to the stock item. If it's true, then we'll proceed on the order. If it's not true, well, then it's removed. Or means if it's a negative, it needs to reorder. So it needs to reorder that the item it's not if the item is not available. Then when if it's true, then we proceed on the delivery item of a certain product. So sequence diagram can show conditional behavior on a separate diagram to keep them understandable. For example, for a use case, we can give the basic path as one sequence diagram and have separate sequence diagram for alternative paths or exception. It uses sequence diagram to show the behavioral of several objects within a case. So we can use state diagram when you want to show the behavior of an object across many use cases. So sequence diagram focus of control or activation. So it can be shown in a sequence diagram as a thin rectangular put on the top of the lifeline of the object. So we have here, this is a thin rectangular put on the top. We have the order, product order, and then stock item. Here's an example of a sequence diagram on an online shopping system. Again, this is our third diagram, the sequence diagram related to online shopping system. So we have the admin, will check the status, the customer, the customer will log in and then will approve to the status whether the customer is an approved client to a certain site, for example, and then it will show the product, and then it will return to the AIP where request order, and then it will return to status. We'll see order status, and then when the order status has been approved, we'll proceed on the receive order and payment. Next is collaboration. Collaboration diagrams show a particular sequence of message exchanged between number of objects. So this is what a sequence diagrams do too. So use sequence diagram to model flows of control by time ordering. Sequence diagram can be better for demonstrating the ordering of the messages. Sequence diagrams are not suitable for complex iteration and branching. We can use the collaboration diagram to model flows of control by organization. Collaboration diagrams are good at showing the static connection among objects while demonstrating a particular sequence of messages at the same time. So this is an example of a corresponding collaboration diagram. We have order and entry window as an object, and then we have the link, the message which is to prepare, and then it will go to the order, and then it will prepare the product order. It will check on the stock items, and then if ever that it's true, if it's true, then it will be delivered. If it's not true, then it will be considered as a reorder item. So this is a collaboration. Again, this is a collaboration diagram on online shopping system. So a certain customer will log into an online portal. It will search and it will check on the inventory. If it's available, then it will add on the item and then put on the shopping cart, process the order, and then the payment details, order summary, and then display the order details to the online portal. The confirmation will definitely the confirmation of the order must be proceed. Next is the state diagram. So state diagram are used to show possible states a single object can get into. It shows states of an object. So how object changes states in response of events shows transition between states. UML state diagram are variation of state charts. State charts are hierarchical state machine, and then state charts have formal semantics. So state diagrams, states, are represented as rounded box which contain the state name. So the following are optional field. We have the entry and exit action. We have the internal transition. We have the activity and then the deferred event. So here is an example of a state diagram. We have the tracking. So entry action will be entry, exit action, internal transition, which are the new target, activities to do, and then the deferred event, it's a self-test or slash defer. So note that entry, exit, do, and defer are just the keywords. So state diagram in a transition. Transition is a sort state and the target state. So we have here two diagram that show by the arrow representing the transition, and then we have the trigger event. This is the event that makes the transition fire. Guard condition, it's a Boolean expression that is evaluated when the trigger event occurs. And then the action is an executable atomic computation that can directly act on the object. And then initial and final state, it shows as filled black circle and a filled black circle surrounded by an unfilled circle respectively. So here in an example of a state diagram, on the top it shows the initial or the default state. So it will enter into a checking, so to check the item, and if it's cancelled, well, definitely it shows the final state. So state diagram example on a state order object. So we have to get first in the item, we'll check the item, and then waiting for the item. If it's already checked and all items are available, it will proceed on the dispatching. Um, if the checking is cancelled, will definitely uh, it will it will be cancelled. If it's dispatched, if the order is available and need to be dispatched, then it will be delivered and then to execute. Okay, this is the state diagram on the superstate. Man. So this is an active is a superstate with substate checking, waiting, and dispatching. So we have here to get an item, same process a while ago, but as you can see, and compared with the diagram on the order object, this is more on an organized manner because if it's waiting, then definitely it's cancelled or delivered. The state diagram in a concurrent state. Payment authorization is done concurrently with the order processing. So we have to authorize, say, for in our diagram, authorizing, do, or check payment. So payment is not okay, then it will be rejected. If it's authorized, then it will be delivered. This is on the concurrent state diagram. So here's another example of a state diagram on a concurrent state also. So if still this is more on organized manner, which you can see that there are some uh, function inside the big triangular box that if the payment is not okay, then it will be rejected. If it's authorized, then it will be delivered. If it's waiting and it's cancelled, then definitely it will be cancelled. So an arrow on the delivered is this is the transition that can only be taken after the both concurrent state reach their final state. So state diagram is good at describing behavior of an object across several use cases. As you can see in our example, we have different type of cases presented here, and then it used them to show the behavior of a single object, not to many objects. Do not try to draw state diagram for every class in the system. It used them to show interesting behavior and increase understanding. So here is a state diagram in an online shopping system. uh, First we have to register, and then we have a separate diagram for all different cases. So after logging in, after registering or logging in, if the customer is already have an account, then he can already or she can already view item, add to cart, search product, and then remove item, see shopping cart, and then check out. So as you can see on this diagram, this is more of a clear manner in terms of the process, because the register and then the login, it's in a separate it's an outside format. It's not mixed up kumbaga, on the diagram. So next is the activity diagram. So activity diagram show the flow among activities and actions associated with a given object using activity and action states, transition, branches, merge, forks, and joins. So activity diagram derived from STL or state diagram that have formal semantic. So activity diagram has activity and action, Activity represents a task that has to be performed, and action is the atomic computation, which changes the state of the system or returns a value. So here's an example of an activity diagram. So as you can see, we have the initial state, we have the receive supply, choose outstanding order item, and then assign goods. So messages can be action or activity states, and then the arrow down is the transition. So transition can have a guard condition. It's also multiple trigger symbol is used to show iteration. So activity diagram branches. We have the conditional branches that you can see on our example. We have authorized payment. So this is the branch. This is a an oval. I no, it's a diamond. It's a diamond shape. We have to guard expression for succeeded or failed. So if ever that it's failed, we have to cancel order. So if ever that the order is succeeded, then it will have to dispatch. So activity diagram, forks, and joins. So what are these? So forks and joins are used to model concurrent execution paths. So it allows parallelism and synchronization. Forks create concurrent threads, joins merge different threads, and both allow a synchronization. So we will receive the order, and then we have a line. We'll consider this the fork, and then under this, we have the authorized payment or the check order payments, and then another line which we considered as the join. So two threads are executing concurrently on this example, and then the dispatch order. So another here, this is also an example of a fork and joins. So we have the fork um, receive order items, and then under the joins we have the stock assigned to all order items and payment authorized. So an activity diagram, we have different elements that we can use. We can use a round rectangular represent activity or action. So example, customers order and order string. And then we have the solid circle. So example is the first action to do. And then we have the diamond represents decision. It's like also in a flow chart. And then customer drinks, drinks is alcoholic. Make sure the customer is at least 21 years old. And then the dotted circle represent end of the workflow. That will be the last action to do. So we have another example, an activity diagram. As you can see, we have activity 1, activity 2, 3, 4, 5, and then 6. So on the right side, we have, say for example, the activity 1 is to receive order, and then working concurrently, we have the forks. Working concurrently, we have to fill order and then send invoice. And then after the fill orders, we can overnight delivery, and then if it's regular delivery. If it's after sending the invoice, we'll receive the payment and then the close order. So these under the fork and the joins, those are the tasks that work concurrently. Activity diagram again on the online system. We have, I haven't found on the customer side, but I found an example of an activity diagram for the admin side. So we have the login and login of the customer, and then the admin side will authenticate. But if it's valid, then we proceed on the add category, add item, manage order, and then manage user. If it's invalid, then it will return to login. Okay, and then under add category, we'll proceed on the modify detail, change, confirm, active, user, and edit item. So here in our example, the fork is on after the diamond, and then before the logout is the joins. So here is an example of UML modeling tool that we can use if ever that we will be deciding on creating or developing a UML diagram. We can use this example of a Lucid app. We will just have to log in or to sign up for this platform. This is for free. This also there are some features that needs to be paid for in advance features maybe, but basically as I'm checking for this app, that will be enough. All of the diagram are available already to develop our UML modeling. This is a video. So we can see a shapes cross and then a cloud, right? Down arrow, then we have the left arrow, up arrow, and then a circle. So these are available shapes that we can see on this app. And then the UML class diagram, we have the class, so we can use this. And then we have the class also, class diagram, interface, class constraint, and so on. So under the UML course case, we can use yeah, and so on. So we have here the example here. We have also the stickman. So under the file, we can see these are the known drop down arrow. So how do they all fit together? Its functionality we can use in terms of functionality, we can use the case diagram. If it's for decomposition, actually we are really talking in the class diagram, it's package diagram and deployment diagram in terms of the architecture. But in our discussion, I already only discussed the class diagram. If we are concentrating on the behavior, then we can use the state diagram, activity diagram. If we are focusing on the communication itself, we can use the sequence diagram and in the collaboration diagram. So the requirement analysis specification, if we are be needing this kind of activity, we can use case diagram. If we are focusing on the design, we can use the class diagram, activity, state diagram, sequence and collaboration, and then the package diagram and deployment. So, we therefore conclude that UML is a standardized specification language for object modeling. There are several UML diagrams that we can use. Use case diagram, this is more on the actors and the software itself. And then we have the class diagram, is a model class showing static relationship among, including association and generalization as per discussed. And if we have the sequence diagram, we can show the way the objects are interact with each other as messages are passed between them. And if we have the state diagram, it shows the state, the event, the cause, and then the transition. It's also considered as dynamic model reflecting the behavior of objects and how they react to specific events. And then the activity diagram describes the state of activity by showing the sequence of activities performed. So here are my different resources. Thank you for listening.